Okay, so let's have a look at the gradient and intercept of the form y equals a plus bx. Well, probably more familiar to most of us is the form y equals mx plus c. Both tell us the same things. The key things are that the gradient of the line is this value here in front of the x. So whether it's an m or a b, it's the coefficient of x is the gradient. The y-intercept is over here. It's the constant on its own, the a term or the c term if you like. Okay, so let's have a look at some of these examples now. We'll just set up a table just to keep things a little bit more organised. So let's just organise our y-intercepts in our table. So let's identify the value on its own. The value on its own here is our y-intercept, so that's going to be equal to 5. And the value in front of x, the x coefficient, is our gradient. So in this case, m is equal to 3. We have a look at our next example now. Again, the value on its own, y equals 10 minus 5x, so y-intercept is 10, the gradient, the value in front of x, negative 5. Example C, we need to rearrange first into y equals mx plus c form. So let's take 3x across by adding it to both sides, divide everything by 2, so 6 over 2 plus 3 over 2x. That gives me a y-intercept of 6 on 2, which hopefully we know is 3, and my gradient as 3 on 2, so m is equal to 3 on 2. And let's leave all of our fractions as fractions. Don't work with decimals. It's much nicer to work with fractions as we go forward. Finally, y equals 7x. Well, that's equivalent of y equals 7x plus 0. So our y-intercept here is obviously going to be 0, and our gradient is going to be 7. Another form of our straight line equation is called our point gradient form, and that form is simply works with the gradient of our line but also a specific point that the line goes in. So that helps us determine our c value, and we'll look at a few more examples of that. Okay, so we'll see here, there's two ways we can approach finding the equation of our line. Let's work with our y equals mx plus c, which is what we're familiar with. So the gradient is negative 2, so y equals negative 2x plus c. And we go through the point 3, 2, so let's substitute that in. X is 3, y is 2, so 2 is equal to negative 2 times 3 plus c. 2 is equal to negative 6x plus c, so we take our negative 6 across and we'll get 8 is equal to c. So therefore the equation of the line that goes through the point 3, 2 is y equals negative 2x plus 8. An alternative method is to use that point gradient form, y minus y1 equals m, x minus x1. And we just substitute all the values that we've got in one hit. So y is equal to, the y1 value is 2, equal to negative 2 times x minus the x1 value is 3, or negative 3. So let's expand and group everything together. Y minus 2 equals negative 2x plus 6. Take the 2 across, we get y equals negative 2x plus 8. So same answer, just a different approach. Example 12, exactly the same thing. The points that we've got to work with, point 1, point 2, a little bit messy, so we'll just work with those as they are. y2 minus y1 over x2 minus x1 is negative 2 minus 1.75 over 4.5 minus 3. So we get negative 3.75 over 7.5. Now we can, if we have a calculator, simplify that to minus a half, or if we just look at that we might see that relationship already. So I'm going to use my point gradient form. So y minus a y1 value. I'm going to use the second point because 4.5 is nicer to work with than 1.75. So substitute the values in, y equals plus 2, negative a half times, multiply. I might change 4.5 into a fraction, so we'll make negative 9 on 2. So we'll get our y plus 2, multiply my negative a half through, and that's why I've made it a fraction, because I think it's a bit easier to multiply fractions. So you get a positive 9 on 4 because of negative negative. Subtract 2 from both sides and I get y equals minus a half x plus 9 on 4 minus 2, which is minus 8 on 4. Let's get a common denominator, remember. So y equals negative a half x plus 1/4.